So if you want to know your grade, average the homework assignments, add the test grades that we have up to there, and average those in. And it goes all the way over here. So I'm hoping that we'll finish everything by the 14th week. They'll give us a week and a half to review and get everything ready for the final exam. All right, so that's aside. Next thing, I want you all to do this first before we go any further, without using your notes, with what you remember, what you should remember, because whenever you come into a classroom, especially in math, the last thing you should do is play with your cell phones and text. Because if you read any of those messages you sent this morning with your friends, if there's anything in there that's in the least bit important to your education, to your career or anything, then it's okay. But if it's just talking to your friends about benign crap, that should be left outside. You shouldn't even worry about ever in this classroom. Because what I'm going to do, if I come in here and I see students not reviewing their notes, but having chats on their cell phones, then yeah, guess what? I want to see what you remember from last time. We'll have a quiz. Because I want to see what you remember. So for right now, I want you to do 3 things on here. Grab a couple sheets back there. I want you to show me the graph of each of these functions. Tell me the domain and range. So do that for the next 10 minutes. The library functions. What the purpose of this sheet is to give you the basic idea of, just by looking at an equation, you can tell what the graph's going to look like, what the domain range, what the end behavior of the graph. What is end behavior? When we talk about end behavior, what are we talking about? At the end, exactly, yes. Because these are continuous functions. So both ends point either up, down, opposite directions. And that's what we're going to look at. But after we finish, of course, the practice test, we set like 10 more questions there. Grab a couple of sheets. All right, so let's begin in this one. So the graph of this one looks like what? Diagonal going through the origin. So from there, what is the domain? Very good. When we say all real numbers, we're saying everything from negative infinity to positive infinity, or we can simply just write the all real number sign. It kind of looks like the realtor's symbol. What's the domain? And the range? All real numbers. I got my questions confused. So, does it have an asymptote? What is an asymptote? Where? Right. An asymptote is a horizontal or vertical line where the graph of the function approaches but never touches. Because like for the vertical asymptote, it's where that makes the function undefined. For example, 1 over x, you can't divide by 0, so x cannot be 0. So 0, x equals 0 is the vertical asymptote. So there's no asymptotes there. How about absolute value? What does that look like? Very good. Why is it a V? Because it has to be positive. X itself is a linear equation. There's no power, there's no division, there's no square root or anything. So no matter what you put in there, x is positive or negative, it's going to come out positive. So when x is 1, y is 1. When x is 2, y is 2. Conversely, when x is negative 1, y is 1. When x is negative 2, so what you have there are two linear equations. The domain, all real numbers. Range, all positive from 0 to infinity. Or we can say why is it a bracket there, parenthesis there? But yeah, 0 can be included. Can you ever get to infinity? No, that's why it's always parenthesis. So far, so good. Everybody's batting 1,000. Quadratics. Very good. What is that name of that graph? Right. A parabola. What's its domain? Pretty much you say all the numbers, you get most of these right. What's the range? The radical function, square root. Very good. Yes. At 0, if you don't remember what these were, you always just plot some points. 3 questions you always have to ask yourself. Can x be negative? No. Can x be 0? Square root of 0 is 0. Can x be positive? So we know that we're only to the right. And as x grows, so as x grows further, it curves like this. Domain and range. For both of them, right? Yeah. So you can say x is greater than equal to 0. Y is greater than equal to 0. So either one of those. It doesn't matter. Whatever method you want to write down the domain and range, is whatever is good for you guys. Is there an asymptote? Is it an asymptote? Because remember, an asymptote approaches infinitely close. This one, it just flat out stops at 0. So there's no real asymptote there. There is an asymptote here because the curve comes in infinitely close. It just stops at 0 and goes back up. So anything below 0 doesn't exist. So far, so good. How about cubics? What does a cubic function look like?
Like parabola half, right?
Just half?
Have this one opposite.
Looks like you're dialing a phone. You're absolutely correct. Basically, what's the difference if the degree is even, it can always go up because it can never be negative. If the degree, the highest exponent, is odd, that means it can be positive or negative. So what happens is this half, if x is negative, the answer is negative. So it looks like this. Basically, this half, the negative half, flips over. So in even degrees, you only have positive answers. Odd can be positive or negative or 0. How about the cube root function? Yes, it's like a stretched out S. It's similar to this one, but now since it's an odd root, it can be negative. I paired up these last four for a reason. How are quadratic and radicals square roots? How are they related? Not half. I know what you're trying to say, but it's not half. That's what happens. It's the inverse. In other words, squares get rid of radicals, radicals get rid of squares. If you think about it, if we had a diagonal line here and we flipped this one over, we'd have this graph. But we can't have negatives. So same thing here. If we took this diagonal and folded it over, we get this graph. That's how you look at inverses. Just fold the graph over that. And that's what you get. So now instead of going up, it now goes out. This one, instead of going down, it now goes out. How many of y'all got that first page right? Okay, let's look at domains and ranges. What's the domain and range of cubic? Told you, if you just say all real numbers, you'll be right most of the time. And cube root? All real numbers. Believe it or not, that was the easy page. Now, how many of y'all started this side? Okay, let's work it together. Whenever you do sheets like this or any activities, always do the easy ones first. The reason for that is if you get stuck in a hard one, you'll be there forever and you'll leave everything else blank. So on this page, which one's the easy one? The last one, the constant. For this one, I said, for example, what if we had the equation y equals 2? What do we know about that graph? It's a straight line. What kind of line? Horizontal line. Why is it a horizontal line? Yeah, because no matter what x you give me, y is always going to be what? 2. And you can only have an intercept if you have that letter in the equation. There's no x, so we can't have an x-intercept. So in other words, it can't move. So it's got to be horizontal. Through 2. Domain. All real numbers. Range. Exactly. It's whatever that constant is. Okay. The next easy one in this equation, this page would be what? Okay, let's look at 1 over x. What does that one look like? Well, let's look at it. If you ever get stuck, do an XY chart. Can x be negative? Yeah, because if you make it just makes it negative. Can x be 0? No. So since x cannot be 0, we have an asymptote. It cannot cross this line. And x can be negative, x can be positive. So if x equals 1, What is y? 1. So we know we have a point at 1, 1. When x is 2, 1/2. When x is 10, 1/10. So what do we notice? The bigger x becomes, what happens to y? So yeah, so we know from here, it keeps on going and going, going, going. We have a horizontal asymptote at 0. What happens between 1 and 0? What happens there? So if we had, let's say, 1/2, if x is 1/2, what is y? You're asking or telling? Yes, well, it is true. Because what you have here is 1 over 1/2, which is 1 over 1. Take the top one, leave it alone, and flip the bottom one. So whenever you have 1 over x, whatever the denominator is, so if we had 1/10, which is very close to 0, we get 10. 1 over 100, we get what? So the smaller x becomes, the larger, higher up it goes. So this, we go over here. And the same thing with the negatives. If x is negative, the whole thing's gonna be negative. So we have this graph here. That's what that graph looks like. What's the domain? Zero. Because yeah, as you look at the graph, we go all the way from negative infinity all the way up to 0. So we have negative infinity all the way close to 0. And then same thing on the other side. We have a union of 0 to infinity. We just cannot have 0. Same thing with the r. From negative infinity to 0, 0 to infinity. Is this sort of an odd or an even function? Why? Very good. Yeah, yes, that's exactly why. Because if we were to rewrite this as an exponent, what would it be? What's the power on the x? 1. So since it's on the bottom, it would be x to the negative first power. So since the exponent to the degree is -1, it's an odd number, it's an odd function. So you're right. Because it's odd, it is symmetric about the origin. This one is even. This one can be rewritten as -2. Since it's even, can the answers ever be negative? No, because if you put a negative x in there and you square it, it becomes positive. So we can't have any negatives. So basically what that means is what happens to the negative numbers here? They rotate. They become all positives. So what we have in this one is the Atari symbol. Because if you put positives in there, it stays positive. But if you put negative in there, it becomes positive. So it looks like that. The domain, exactly. It's from negative infinity to 0, unioned with 0 to infinity, because we have an asymptote. The range. Can you include zero? No. So it would be parentheses 0 to infinity, or you can say y is strictly greater than 0. The next easy ones would be these two. The exponential function, what does that one look like? What is its property? Exponentials have two basic properties. For example, this example is, what if we had y equals 2 to the power x? B is an integer. It has to be positive. Why is that an important concept? If it was 1, what would happen? 1 to any power is what? It's 1. So it'd just be a horizontal line. Boring. If it's 0, 0 to any power is 0. So again, it's a horizontal line. If it was negative, what would happen to the graph there? If b was negative. Okay, first off, can x be negative? Yes, it can be. Can x be 0? Yes, it can be. Can x be positive? Yes, it can be. Let's look at those. So the rule we have to live by here is this. If you have x on the bottom and you want to bring it up on top, just change the sign of the exponent. So if you have a negative exponent, doesn't make the answer negative, it simply makes it very small. That's the first one. The second one, x to the power 0 is 1. And then thirdly, if x to the power n and n is positive, then it's going to be greater than 0. It's going to be some positive number. Those are the rules of exponents. Now, on exponential functions, 2 to the power x. If x is negative, this is x, and this is y. So if x is -3, what do we get? We have 2 to the power -3 is the same thing as 1 over 2 to the positive 3, which makes it 1/8. If x is -2, 2 to the power -2 is 1 over 2 squared, which is 1/4. 2 to the power -1 is 1 over 2 to the first, which is 1/2. Notice the answers are still positive, even though the x's are negative. If x is 0, what happens? It becomes 1. So in exponential functions, it always crosses the y-axis at 1, unless there's a vertical shift. But the functions, basic functions, always cross through 1. And if x was positive, so x could be negative, positive, or 0. but the y values are always positive. The bigger the positive, the bigger the answer. The further you go in the negative, the smaller the answers. So what does that tell us? What's the graph going to look like? Right. It's a continuously increasing function. So the bigger the negative, the lower it gets. And then the positive, and it always crosses through one. That's an exponential function. The domain, can all real numbers, because it could be negative, 0, or positive. How about the range? Can the answer be negative? No. Can it be 0? No, it doesn't have any x-intercept. So it's only positive. So it's greater than 0. Y is greater than 0. That's the basic exponential one. Now, the reason the base cannot be negative. If we had to say -2, let's see what happens if we plot some points. Let's get some values. Let's say -3, -2, -1, 0, 1, 2. So when x is -3, what do we get? When x is -3, we would get, which would be 1 over -2 cubed. What is -2 cubed? Right, so it's 1 over -8, which is -1/8. At -2, what do we get? What is -2 squared? It's a +4. Which is -1/2. -2 to the 0 is 1. -2 to the first power is -2. -2 to the second power is -2 to the third power. So what do you notice about the y values? It's got an oscillating function. It alternates between negative, positive. So it goes from up, and it gets bigger and bigger and bigger. The further x goes to the right, the larger the value gets. So we can't have that because it's not a defined function, because we can't predict what's going to go on. So that's why exponential functions are always base. The base itself has to be greater than 1. All right. How about logarithmic equations? What do they look like? How many types of logarithmic functions are there? This is a review of algebra. More or less than 10? Fifty-fifty shot. It's less, very good. More or less than 5? Eh. More or less than 2? More than 2. There's actually 3. Logarithmic functions. Depends on the base. Instead of A, I'll call it a B, because that's the base. That's the base. If the base equals 10, if the base equals E, if the base equals anything else. If X would be anything else. If we have a base 10, what's that called? What's that? Natural log. Very good. Why is it called a natural log? Actually, no. It's not a natural log. I'm sorry. No. I'm getting ahead of myself. It's not called a natural log. It's called a common log. What base is our counting system in? 0 through 9, or we have 10 digits. It's a base 10 system. So if we have a base 10, we call it a common log, which we write like that. Notice, if there's no base, we know that the base is automatically 10. If it's a base 10, there's no base on it. It's nothing there. If we have a base E, now we got a natural log. E is a constant, 2.718174. It's a irrational number, never stops. When we have a log base E, we have a natural log. ln x equals y. So whenever you see ln of something, we know it's a base E. And any other number has to be written there in order to be able to do it. So those are the 3 types of bases, the 3 types of logarithms. And the base tells you which system to use. Now, the reason these 2 are separated, because that's what most of the universe works on. Either our common base 10 system, or has to do with the natural event occurrence of things. And if you look at a calculator, any calculator, on the scientific calculators, you notice you see these two down here. Oop, ln and log. There is no log base 5 or log base anything else. All you have are these two logs, ln and log, base 10. So what do you do if I give you an equation like this? How would you give me the answer? You can use a calculator if you want to. Won't do any good because there's no key like this. So you can just poke numbers all you want. There's one formula you have to use. If the base is not 10 or E, then you must use the change of base formula. In other words, if I gave you log, what was that one? Log base 3 of 5. What we have to do is we have to convert this equation into either log base 10 or log base E. If we use log base 10, we would write this. That's the change of base formula. Whatever the operation is, that one goes on top. Whatever the base is, goes on the bottom. Same if we want to use ln. You can use log base 10 or you use ln. Doesn't matter which one you use. Because the ratio is going to be the same. Now you can use a calculator. So that's a very important, because we're going to spend a lot of time in this class doing natural logs, exponential logs, and so give you any other base, you can convert them into before we do any type of calculations on it. So this opens up the rest of the world for us in logarithmic equations. So if you're going to look at the change of base formula, this is the change of base formula. Whatever the base is, remains the base on the bottom. Whatever is on top stays on top. And the last one. The greatest integer function. What does the greatest integer function look like? And what does it mean? This one here. Have you ever seen that function before? You had in algebra. This where it's first introduced. Basically, what this function is used for is if you want your answers to come out as nothing but integers. What this function does, it truncates the decimals. In other words, it erases the decimals. So from at 0, the answer is 0. 0.9 or 0.5, it's 0. When it gets to 1.0, it jumps to 1. And then stays that way till it gets to 2.0, then it jumps to 2. It's called the stair-step function, as you can see why. Basically, what it's really saying is you just round down. It's a stair-step function. So what's the domain? And what's the range? For the domain, it's all real numbers. Because when it goes, it always keeps on going. Every number on the x-axis is allocated for. How about the range? What is its range? What are the y values? Very good. I think it's either I or N. That's natural numbers. That'll be I, integers. Integers. Ooh, we skipped one. The logarithmic function. We were getting there, but I got side detoured. So remember, the exponentials and logarithmics are inverses of each other, which means I flip it across the origin. I mean, the y equals x-axis, which means my graph will now look like this. Logarithmic functions, you cannot input zeros or negatives. So the domain is simply from 0 to infinity. The range goes from negative to positive, so it's all real numbers. Everything we're going to deal with are these. The reason we have to know what the graph looks like is to be able to come up with solutions. Also, later on in calculus 2 and calculus 3, we're going to start dealing with rotations of solids. So if I give you this function here, and I said I only want from 0 to 4, I want that rotated about around the x-axis, so I have a solid. You'll have to know the functions and what they look like. Okay, I'm trying to put this to memory. It'll make your life much easier for us later on. Okie doke. Now, back to the test. We left off at question number 14. Graph the function by starting with the graph of 1 over x and applying the transformations to get y equals 1 over 4x minus 1. So when we graph equations, the first thing you want to start off with is what is the basic function that this one deals with? From the library of function, which one is this? The rational. Yes, so we know that the basic graph will look something like this one, which looks like this. So the second thing that happens is we multiply the bottom by 4. What does that do to our graph? So when x is 1, y is 1. When x is 2, this is for this one. 1/2. When x is 3, we get 1/3. So that's the original function. Now, if we put a 4 in front of there, so when x is 1, what is y? 1/4. When x is 2, 1/8. Very good. So what's happening to the graph? Compare the two equations. So it's 1/4, 1/8, 1/12. So what's happening from our original function, our original graph looks like this, to what's happening to the points? Instead of 1, 1, we now have 1, 1/4, 2, 1/8. So what's happening here is the graph is getting smushed. It's getting compressed. What's the next transformation? So we have the 1 over x, 1 over 4x. Now we gotta do the -1. What does the -1 contribute? It's the vertical shift. It tells us to do what? Go down 1. So our original intercept was here, so we go down 1. This is my new origin. So my graph will look something like this. The graph just shifts down 1 unit. Transformations only really just move the origin to a new location. So it moves the origin from here down 1. The graphs look the same. So with that, which graph is it? You're asking me. What's wrong with C? It's flipped because this side's going up, this side's going down. So it can't be C. Bless you. What's wrong with D? It's shifted to the right. We didn't do that. So it can't be D. What's B? Why is that wrong? It went up. So the answer is A. Number 15, the value of cosine x is given. Find sine x and tangent x if it lies in a specific interval of this. They're saying cosine x equals 1/2. And x is in the interval pi over 2 to 0. We have to find sine x and tangent x. So how would you go about do that?
One. Fine.
One more time?
So, when you look at cosine, you look at like x over h or something.
Ah, okay. What is that? What is that little small saying that we learned in trig? SOHCAHTOA. So, TOA. Sine x equals opposite over hypotenuse. Cosine x equals adjacent over hypotenuse. And tangent x equals opposite over adjacent. So here's our angle x. Adjacent touches that angle. Opposite is opposite of it, and the hypotenuse is the long side. So what does this tell us? Cosine is adjacent over hypotenuse. So the adjacent is 1 and the hypotenuse is 2. What's the opposite side? How do we figure it out? Pythagorean theorem. So we have 1 squared plus b squared equals 2 squared. Which gives us 1 plus b squared equals 4. Subtract 1, b squared equals 3. B equals square root of 3. So the sine is adjacent or is opposite over hypotenuse. Square root of 3 over 2. Now, is that correct? Does this come into play anywhere? In our unit circle, which one deals with negative pi over 2 to 0? The negative pi over 2 is down here. So we're looking at down here. So is it going to be positive or negative? Why negative? Or why positive? Very good. That's exactly what it was. Cosine is the x-axis. Sine is the y-axis, is the y value. Since it happens in this quadrant, it's all negative. So we know the sine value is negative and the cosine value is positive. What's the tangent going to be? Well, the formula for tangent, besides this, is sine over cosine. Why do I use that? Because we know sine is negative, cosine is positive. So the answer is going to be what? Positive or negative? It's going to be negative. So we know the sign of the answer is negative. So just look at opposite over adjacent. Opposite is radical 3. Adjacent is 1. So the answer is negative radical 3. Any questions about that? So some of y'all looking at it has 3 heads. Trust me, there's no bad questions, because that's the reason I'm using this for, is to get all the questions out. Because once we start calculus, I don't want to have to go back and teach you basic trig or algebra anymore. So if there are any questions, spit them out. Yes. If we had 2 over square root of 3, then we'd multiply top and bottom by radical 3. We multiply by radical 3, rationalize the denominator. Right. I'm glad you asked that, because you never want to have a radical as an answer, final answer. The common convention of mathematics says that. Number 16. The value of cosine x is given. Find sine x and tangent x. So this is from 3 pi over 2 to 2 pi. Also fourth quadrant. This one just went backwards. This is also the fourth quadrant. It's also fourth quadrant. The fourth quadrant tells us that the sines are negative and the cosines are positive. So SOHCAHTOA, it says that adjacent is on top and hypotenuse is there. We just have to find the opposite. So we have 4 squared plus x squared equals 5 squared. So sine x is equal to no. Negative 3 over 5, right? Because we're in the fourth quadrant. And then tangent is the opposite, which is 3 over 4. Also negative, because we're in the fourth quadrant. Pretty straightforward and easy. I shouldn't say that. I mean, it's been sometimes since you had this stuff. As I should say, does it bring back memories? Like, Ghosts of Christmas Past. Number 17. For number 17, it's asking the graph of sine x and sine magnitude of sine x together. What are the domains and ranges of sine x? I'm unfamiliar with that symbol. Anybody remember what that symbol means? It's what? I don't know what it means because they also have a sine x right here. To me, they look both the same. Well, let's figure it out. So, what is this asking? What are the domain? Okay, so if we graph both of these together, what do we get? So, which one of these is the sine function, first off? Sorry. Is that the sine function? Is that the sine function? Is that? What does a sine function look like? Let's begin. Does sine deal with the x or the y value? So this is 1, 0, 0, 1, -1, 0, 0, -1. So at pi over 2, sine is 1. At pi, sine is 0. At 0, at 3 pi over 2, it's -1. And at 2 pi, it's 0. So the range is from -1 to +1. We have pi over 2, pi, 3 pi over 2, 2 pi. At 0, what is sine? 0, so it's there. At pi over 2, 1. At pi, 0. At 3 pi over 2, it's -1. And at 2 pi. So we know the sine function looks like this. Let's see what the difference of those are. So, oh, that's why. So which ones can it not be? Yeah, it cannot be C and D because that's the cosine function. What I'm thinking this function here represents I'm thinking it's B because the intercepts are, it's just where the function exists there. at the endpoints, that doesn't exist. And this one, these are just flips. I'm saying it's B. Just my observation. Why would you want to have it negative represented? So I'm saying B. Again, I will find out what this symbol means because they use it for some reason I've never seen it before. It's not the absolute value. So the domain of sine x is what? What's the domain of sine x? All real numbers? And the range of sine x? Is the range an interval or is it a list of numbers? That is what it means. Because the graph here is the sine function. This little thing says so we have pi over 2, pi, 3 pi over 2, 2 pi, from 1 to 0 to -1. So the graph itself looks like this. So from here to here, what happens between here and here now? Because it's so the graph itself is either 1, 0, or -1. This is the range. And since it goes up, the lower bounds are not included. The lower bounds not included. So that's what I think that symbol there means is the lower bounds on the domain of the range is not included. But again, I will find out for you and define it better. But I've never seen a symbol, but I'm saying that that's what it means. It makes more sense that way. So this one is a list of numbers of 1, 0, -1. And that's what those lines there represent. Yes, okay. Find the function value of cosine squared 7 pi over 8. Where's our cheat sheets? Get your formula sheet out. A and A. It's A and A because for that one, it's A and A. Oh, there we go. All right, so where's cosine? What's the formula for cosine squared? That's yeah, yes. Well, find out which sheet that's in. I should consolidate these sheets, shouldn't I? A half. The half angle is cosine pi over 2. I want cosine squared. Yeah. Okay, let's figure this out. Cosine squared 7 pi over 8. So we have cosine 7 pi over 8.
So it's a 1 plus cosine 2, 7 minus 3.
What's that?
I mean, on my notes, I put it's 1 plus cosine 2 theta over 2 is the formula. So then, the theta, you just fix it with 7 pi over 8. And then over 2 the whole thing.
Yes. That's the half angle?
Yeah.
Yeah. Right, and so a theta, this is theta. We have 1 plus cosine 2 times 7 pi over 8 over 2. So that 1 plus cosine 7 pi over 4. And what is 7 pi over 4? 4 pi. So that's the same thing as negative 1 pi over 4, which makes it so here's our chart. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi, 5 pi, 6 pi, 7 pi over 4. The cosine is radical 2 over 2. So we have 1 plus radical 2 over 2 over 2. This is 1 over 1, so we have to multiply this by 2. So we got 2 plus radical 2 over 2. Two plus radical 2 over 4. There's the answer. Again, same as I told you about calculus, it's just the first step. The rest is algebra. Okay. So there's that page. Tab 19. Oh, there's 19. Okay, number 19. Thank you for the help. Thank you. Thank you. It's just, yeah, I should just go through and consolidate that entire set. X plus 1, X plus 5. Determine an appropriate viewing window for the given function and use it to display its graph. What do we know about this graph? The options are these. So, given this, what two things do we have to figure out first? Whenever you have a rational expression with x's in there, you have to first find the horizontal asymptote and the vertical asymptote. How do you find the vertical asymptote? Set the denominator equals 0 and solve. So we have x plus 5 equals 0. So x equals -5. That's your vertical asymptote. So we know we have a vertical asymptote here. So looking at this, which graph or graphs can it not be? This one has a vertical asymptote at -5. 1, 2. So it can't be B because the vertical asymptote should be on -5, and that's not the right location. So that's not right. 1, 2, 3, 4, 5. That looks kind of there. And it can't be this one. So it can't be B and D. So that's the first thing. Set the bottom equals 0 and see what the vertical asymptote. Then how do you find the horizontal asymptote? How do you find the horizontal asymptotes?
You just set the numerator equal to 0?
No, but we could use that. If you set the numerator equals 0, what does that find for us? The intercept. The only way you can have a 0 in a fraction is if the top equals 0. So we know we have an x-intercept at -1. But what else do we know? The horizontal asymptote. For any Remember, whenever you have a rational expression, it's always the leading terms that will dictate the shape, the direction, and solutions. You have their coefficients and you have their exponents. Three things can occur. If the top exponent is bigger than the bottom, if the top exponent is equal to the bottom exponent, and if the top is less than the bottom. So it's compare the exponents. N is on top, M is on the bottom. If you have more X's on top than the bottom, you have no horizontal asymptote because it keeps on going forever and ever to infinity. If the exponents are equal, then your horizontal asymptote is simply the coefficients, because then they would cancel. And if there's more on the bottom than the top, then your horizontal asymptote is the x-axis. So what do we know about our equation? What do we know about our equation? Which one does it satisfy? Yeah, this one, but they're both equal. So our horizontal asymptote is 1. The coefficients, 1 over 1 is 1. So we know we have a vertical asymptote at -5 and a horizontal asymptote at 1. So let's see which one of these it can be. This one, A, the horizontal asymptote is the x-axis. So that can't be right. So this one has to be correct here. So it has to be C. Yes.
Well, I just saw that you can calculate it on that way.
You by plotting points. Okay, now I want you to get away from that because you didn't do anything. I want you to learn how to look at these things, because being able to observe how a function behaves, this is a pretty Mickey Mouse equation. This is algebra. It's not even near calculus. So I want you to know how to solve these. It's the mechanics that I'm interested in. Do you know what that means? Because what did you learn from graphing it? No, that's all algebra. Horizontal and vertical asymptotes are all algebra. Well, yeah, but algebra comes first, and so that's you reuse it in trig and in calculus 1, 2, and 3. But we have to know exactly what it means. Looking at a function, I know that the horizontal asymptote, looking at this, that it's going to be horizontal is 1, and the vertical asymptote is -5. So with that, I knew that these two couldn't be right. So from there, I would plot a point. I could plot a point and say if I took -2, if I said x equals -2 and plugged it in there, what do I get? We have -2 plus 1, -2 plus 5, -1 over 3. We have a negative answer, right? It can't be A because that's positive. It can't be B because, well, that's the whole graph is wrong. It has to be C because my solution is negative. I'd look at some points, and then since I have an asymptote at -5, that they have to be traverse of each other. So all these things that you learn in algebra and trigonometry, all these stuff has to be, the better you understand those, the faster you can do all these work. Use your I don't mind using calculators. Use your calculators to check your answers, not to supplement your education, not to replace it. Uh, 21. We do, oh, there's 20. So this one says, determine an approximate viewing window for the given function and use its display to graph sine of 300x. What does it mean by appropriate viewing window? You have to know the period, you have to know the amplitude, all that sort of stuff. So what we have here is y equals sine of 300x. So what's the amplitude of sine? From 1 to -1. Because there's no coefficient here, the amplitude remains, so we know we have a box here. This equation comes into, because we have to look at the period. What is the period of the sine function? In other words, a period is where it starts and where it starts repeating again. It goes from 0 to where? Before it repeats itself. 2 pi, right? So the period is 2 pi over b. This number here is b. So that will explain to why all of these go from negative pi over 150 to pi over 150. And you notice each one of these have the amplitude of one negative one. So out of these three, what is that? Which one's correct for us? What's our frequency? How'd you get D? It is right. D is correct, but how'd you get it? Is this the right graph to begin with? No, it was at 0, it goes down, so that can't be right. This one can't be right. So it has to be B or D. But since it says sine of 300x, which means it repeats itself a lot more than once or twice, this is one long wave. This would be half of or twice as much. This we repeat itself a lot more. The answer is D, because our frame is from -1 pi over 150 to pi 150, 1 to -1, and it repeats itself twice in that term. So the answer, B. Find the domain and range of this function. Find the domain and range of that function. If you rewrite this, how would it look? How would you rewrite this equation, this part? What does a negative exponent tell you? It changes the location of the where it's positioned, whether it's above or below the x-axis of the horizontal line. So as x goes to infinity, what happens to this number? Becomes smaller. Eventually it goes to where? It gets so small, it gets close to zero. So, and the other direction, as x goes to negative infinity, what happens to the function? Because if x was a negative number, so for example, 1 plus 8 negative of negative 10, those cancel. So we have 1 plus 8 to the 10th. 8 to the 10th is pretty big, isn't it? What if I had 1 plus 8 to the negative 1000? Negatives cancel. So we have 1 plus 8 to the power 1000. It's even bigger. So where is it approaching? Where is it going to? As x goes to negative infinity, where does this number go? Notice it's getting bigger and bigger and bigger. So the answer goes to infinity. So the domain can be all real numbers. Because we can have negative x in there, we can have 0, and we have positive x. It's not going to violate the rules. So our domain is all real numbers. The range the smaller, remember, we said that this one here, as x goes to infinity, this number here eventually gets so small it goes to 0. So we get square root of 1. So our domain goes from 1 to infinity. Our range, I mean. Yeah. I have to put a parenthesis there. Why is it a parenthesis there? Because this number never really gets to 0, but it gets severely small. So I'll never get to 1.0. I'll always get 1.0 something. So my range is just that. Determine if the function is 1 to 1. G of x is equal to 9 absolute value of x. Is this function 1 to 1? What does 1 to 1 mean? 1-to-1 means for every X, there is one and only one Y. What test do we have for one-to-oneness? Not the vertical line. Horizontal line. Is it 1-to-1? No. For every one X, there's one Y. For every one Y, there's one X. That's 1-to-1. So no. How about this function? Y equals 7X to the 1/5. Is that 1-to-1? Because it passes the horizontal line test. Number 24. Express this function in terms of ln2 and ln3. How would you do that? What does it mean? What do we have to do?
Power two, or 2 to the power 3.
No. In other words, we want to rewrite this. So this number is made up of a series of 2s and 3s only. So first off, we know what? $54 equals 9 times 6, yes. Because 9 is 3 squared times 2 times 3. Or you can say 3 cubed times 2. So what does the product rule tell us in logarithms? So if we had ln m times n, we can expand that like that. So what this one says is I could take ln because since they're multiplied, I can distribute that to both of those. The 3 and the 3 cancel, so I just have ln 3. Whenever you have an exponent, those come out in front. So our answer is that's our answer. Solve for t. E to the power negative 2t equals 121. E kt equals 1/5. E to the power ln 0.6t equals 0.8. So the first one, we have to solve for t. How do we get rid of the e? If we take the ln of both sides. The exponent comes out in front. Ln e is 1. Because log base e of e is 1. So we have negative 0.2t equals ln 121. Change the signs. So 0.2t equals negative ln 121 and divide by 0.2. That's the first one. The second one, same thing. I've tried to get that one. So I gotta take the ln of both sides. This goes out in front. So we have kt ln e ln 1/5. Oh, okay, good. So that cancels. We have kt equals ln 1 minus ln 5. This is a fraction. ln 1 is 0. So t is equal to negative ln 5 over k. This last one says e to the power ln. These cancel. So we have 0.6t equals 0.8. So T is equal to 0.8 over 0.6, which is equal to 4/3. Nope, I can't do that with a T there. So I take the ln E. Yeah, I can't because I forgot there's a T there. So I have to take the ln of both sides. That comes out in front, so we have ln 0.6t. That disappears. ln 0.8. So t is ln 0.8 over ln 0.6. Yeah. All right, we have two more to finish next time, then we'll start chapter 5 or chapter 2. Okay, everybody. Have a great day. Sorry about that.